So in order to start this graphing using Vertex form, what we're going to do is we're going to take our graph paper, fold it in half, then fold it in half again, and we should get 4 identical rectangular areas. And what we're going to do is we're going to graph this equation, y equals x squared. And in doing so, we're going to go from -3 to 3, and we should get the following set of numbers for x and y. Now, based on this chart here, based on the x complex, there is no movement left or right, no left or right. So basically the x value for the vertex in this case is going to be 0. Now for this one here, -5, based on our investigations, that means our down motion is, our up and down motion is down 5, which means our vertex is going to be at y is equal to -5. So the vertex using x and y is just going to be 0, -5. So let's go and create the table for these values. And we get these numbers for our set. Now, basically, let's take a look at the next graph. This graph, based on the x complex, if we're just looking at its left-right translations, this part here, there is no indication of a left-right movement, so the left-right means that for our x-axis, there's none. So our x value for our vertex is 0. For this one here, for plus 2, this means our up-down is going to be up 2, which means that our y value for our vertex is 2. And so for this last chart, we end up with our vertex being, we think it's going to be 0, 2. And you'll notice that the highest point on this graph, based on the fact that our graph starts as -x squared, means it's opening down, means that we're going to have a vertex of 0, 2. So our highest point on our graph is 0, 2. On the second one, here is our vertex, and here is our vertex for the first one. Now when we graph them, we're going to get something that looks like this. So now, when we graph, our basic graph looks like this, y is equal to x squared. And then, for the next graph, you'll notice we have y is equal to 2x squared minus 5. And we have something that looks like this. Now we also have our next graph, which should look like this. Opening down, but its vertex is at 2, as you can see. For our second graph, our vertex is at -5 and it opens up. But you'll notice that something weird happens. Based on our discussions on graphing using the step pattern, you notice that for this graph here, y is equal to 2x squared. 2 is the base. Now, remember, for y is equal to x squared, the steps are that we use for it are 1, 3, 5, 7, and so on. So, for this graph here, for y is equal to 2x squared minus 5, our steps are going to be multiplied. So 1, 3, and 5 is going to be times by 2 in this case. So we're going to have 2, 6, and 10 as our steps. And if you take a look at the blue graph here that represents y is equal to 2x squared minus 5, you'll notice that if I go over 1 on this graph, one step on this graph, and then I go up, if I go up 2, you'll notice that we hit one of the points on our graph. And then if we go over 1 again, and then go up 6 points, 1, 2, 3, 4, 5, 6, we get another point on our graph. Now based on that, we can use the concept of the axis of symmetry, which literally falls along the halfway mark of our parabola, and then quickly map our points to the opposite side of our axis of symmetry. And then we would easily graph it. So that's what we were talking about yesterday in math class when we were adding to our jargon sheet. Now, continuing on with the worksheet, we've graphed it. You've seen what it looks like. And if we took a look at the second equation, y is equal to 2x squared minus 5. Notice on the x complex, on the x squared complex, there is no left-right movement. But on the movement up and down, there is an up and down movement. Right? So basically what we would say is our translations are the following. The first thing that you want to do is you want to look at the x squared, at the number that's sitting on the x squared term. In this case, it's 2. So you're going to say that this is a stretch by 2. And if you want to, you know what, you should say it opens up as well. And then you also want to say that its left-right movement based on the x complex is no horizontal shift, or another word for shift is translation. Now, for our vertical shift, the vertical shift is down 5. You can say the shift is down 5 or the translation is down 5. So basically, let's take a look at the third equation now. The third equation is y is equal to negative x squared, right, plus 2. Now, the number that's in front of this x squared term is understood to be negative 1. So, first of all, well, the moment that you see a negative sign, it means it's opening down. Two, based on the x complex, there is no h value that is associated with it, so there's no left-right movement. And we'll just write that down. So no left-right translation or shift. And 2, 3, we want to identify its vertical shift, which is in this part here. So its vertical translation is up 2. Now, let's take a look at our last graph. Y is equal to x squared, negative 2x squared plus 1. Based on the same calculations before, we could easily use the step pattern to graph this and use desmos. But what I want to know is, tell me the orientation, tell me the orientation, tell me the stretch, and then tell me the horizontal shift, and then tell me the vertical shift if there is one. pause the video here and do that problem. It opens down because of this negative number that we have here. Our stretch is by 2, and that is identified by the number 2 sitting in front of the x complex. There's no horizontal translation because of the x squared complex. If it was in brackets x minus something or x plus something, then there would be a shift, but it's not, so there is none. And the vertical translation is, the translation is up 1 due to this part of our complex of our equation, the plus 1. You can always substitute the word shift for translation anytime you do these problems. And when you graph this graph, you're going to get something that looks like this. So if we're looking at our original graph y is equal to x squared, we notice that when we take a look at y is equal to negative 2x squared, the negative means it should be opening down. We said that if we look at this just using our vertex analysis that we've done before, that this should be, it doesn't move left or right based on this x complex squared, but then it moves up 1. And let's see what we get. And its stretch is by 2. And we get something that looks like this. You can easily create these by hand by using the step method that I showed you earlier.